This is HL Paper 1, Number 13, Math Applications and Interpretation, November 2022 exam. This is investigating nonlinear modeling, and we can see that Jen believes she has graphed the log base 10 of Q on the y-axis and P on the x-axis. And she's created a scatter plot. Here are a couple of points along that scatter plot, and so we're looking for an equation. We can find an equation of this line initially by finding the slope of the line, and we already have the y-intercept, negative 1.3. So slope, we can find m by doing 14.9 minus negative 1.3 over 6 minus 0. And so when you do that, you get that m is 2.7. Oops. And like I said, we can see b because we're given the y-intercept. Okay. Because we have a line, a linear equation, we graph that just like y equals mx plus b. We put our m here, our b here, and we put our input variable p in the x position and our output variable log base 10 of q in the y position. So I'm going to go down here and rewrite that. Log base 10 of q equals 2.7 times p minus 1.3. So we have found an equation relating, it says find an equation for q in terms of p. We have found an equation relating q and p, but we need to isolate the q in order to meet the qualifications we were asked. So we can do that by raising both sides of this equation to the base 10, which is the inverse operation of log. And there, those cancel, and we're just left with q on the left equals 10 to the 2.7p minus 13 on the right. Let me double check. That is perfectly, sorry, that should be 1.3. And that is a sufficient way to leave our answer because we have an equation for q in terms of p. That answers part A. Let me see, is that A? Yeah, that's A. Part B asks us to state what expression okay, so let me read this. Jen also investigates the relationship between the same data Q and new data. Notice that it's new data R now. She believes that the data can be modeled by Q equals A times the natural log of R plus B, and she decides to create a scatter plot to verify her belief. What expression should be on each axis? In other words, what is the input variable now and what is the output? Again, knowing that this is a linear model, we have the form mx plus b. So natural log of r would be our input or x value, and q would be our y value. So we would just write that for part B. The x-axis is natural log of, was it r or q? R. And the y-axis should be labeled as q. Let me confirm again. Yeah. That was the only thing we had to do for part B. And now moving on to part C. Here we have an A and B given to us for this model. So we can substitute those in. We'll start by doing that. Q equals 4.3 natural log R plus 12.1. Q equals 4.3 natural log R. Was it plus or minus? Oh, plus 12.1. Okay. Now, we're given that information. Let's see what it actually is asking for. Find P in terms of R. So we want something to be p equals and have r as the variable. Let me just write that out to the side. We want to connect p and r somehow. And here we have an equation that connects q and r. And previously we had an equation that connected q and p. Since that is already, they're both equal to q, we can set them equal to each other. And no, hold on. Yeah, we want p and r. Yeah, so we can do that. We can set them equal to each other, and then we have 4.3 natural log r plus 12.1 equals 10 to the 2.7 p minus 13. All right. This is pretty ugly. We've got a lot of work to do here, but let's think about what we want to isolate. We were asked to find an equation for p in terms of r, so we want to isolate p. So let's think of how to get p out of the exponent. In order to do that, we need to take the log base 10, the inverse operation of base 10, so it's log base 10 of both sides of the equation. On the right side, the 10 goes away, and we just have 2.7p minus 1.3. And on the left side, I want you to look and think about doing this. Is there anything we can do to simplify it? I suggest no. You can actually just leave it unmessed with, particularly because nothing easily can be canceled or simplified. So leave it like that. And now you can see all we need to do is add 1.3 and divide by 2.7. And so check out. All we have to do here is write p equals log base 10 of 4.3 natural log r plus 12.1 plus 1.3 on the outside of that whole thing, all divided by 2.7. Now we have an equation for p with respect, or in terms of r, confirming that's what we were asked, an equation for p in terms of r. We've done it, and this is all we need to provide. This is it.